we are looking at lesson 5.4. And as you look at lesson 5.4, you'll notice the first page says long division of polynomials. And in a normal year, I would take 2 days to do lesson 5.4. If I had plenty of time, no concerns, I would do lesson 5.4 over 2 days. I would spend the first day torturing you with long division. And then the second day, if you flip the page, we'll go into synthetic division. Now, this year, I don't have the luxury of 2 days. And so we're going to condense it into 1 day, which means we're going to start with a warm-up problem. This division problem you see here is kind of our warm-up. This takes you back to your elementary days so we can practice our long division. But then we're going to do one polynomial long division here. So I'm going to torture you with one full-out Algebra 2 long division problem. And then we're going to move over to synthetic division. Synthetic division is much easier. Takes a little bit to catch on of how all the numbers work, but it is much easier than the long division. Okay? I don't think any problems in homework actually require you or say you have to do long division. You can use synthetic division on all of them. Okay? So, just kind of an FYI there before you tune me out today and be like, long division. Nope, I'm done. Give it a shot, guys, okay? Now, okay, elementary days, we're going to do 12 divided into 15,248 without our calculators. I know it's a crazy thought, but we can do it. Okay, so when we start this, and the whole point of this, I'm going to go step by step here to help remind you how to do long division. Because I've learned over the years, if I remind you before we get into this one, it goes a little bit better. So, when we start with 12, 12 is a 2-digit number, right? So we usually go into another 2-digit number. So you're asking yourselves, how many times does 12 go into 15? How many times does 12 go into 15? Once. Where do I put that 1? On top above the 5. If you're going 2 digits into 2 digits, we're going over the 5. Then what do I do? Okay. We're going to put the 12 under the 15. Now, it's technically doing 1 times 12, right? Whatever the number this is, 1 times 12 is 12. And then we're going to subtract. 15 minus 12 is 3. Now what? Okay. Drop down the 2. Repeat the process. How many times does 12 go into 32? 2. I'm going to put that 2 up above this 2. 2 times 12 is 24. Then again we subtract. 32 minus 24. 8. Now we drop down the 4. 12 into 84. How many times does 12 go into 84? 7. Put the 7 above the 4. 7 times 12 is 84. 84 minus 84. 0. Now, drop down the 8. 12 into 8. It doesn't. It goes 0 times. Where do I put that 0? Put the 0 in our answer above the 8. And what is this 8 down here? A remainder, yes? You know, in elementary school, you got to write 1,270 R8, remainder 8. Well, we don't do a whole lot more than that right now with synthetic division. So, let me use my big words. The quotient of this problem, quotient is answer to a division problem, so my quotient on this problem is 1,270, and my remainder is 8. Okay. Does long division sound a little familiar? Okay. I really just wanted to review that process before we jump into an actual long division problem. So, let me set up long division. What goes in my box with long division? And this is looking at the actual example 1 here. It says using polynomial long division to divide 4x squared plus 23x minus 16 by x plus 5. What is the quotient remainder? So what goes in the box? Which equation?
The one with the squares.
Okay, so 4x squared plus 23x minus 16. So my divisor that I'm dividing by, x plus 5, goes outside the box. Okay, if you think about the problem we did on the last one, we looked at the idea of 12 into 15, right? First 2 digits into first 2 digits. Well, over here, we have 2 terms. And so, yes, in a way, we're looking at x plus 5 into 4x squared plus 23x. But that's a little more confusing than it needs to be. Just worry about the first term right now. That's going to help me get the first part of my answer. Part of me wants to say, how many times does x go into 4x squared? But a better way for me to ask this is x times what is 4x squared? So this x times what is 4x squared? 4x if you're a little hesitant on how people got x times 4x is 4x squared, you can also think of it in terms of division. That 4x squared divided by x is that 4x. So it's kind of, however you see it best. Now, where am I going to put that 4x? Not on top of the 4x. On top of the 23x. Now, he's just going to work her way down the row, aren't you? Till I just say yes. Okay, now, here's my reasoning. Officially, even though we worked only with x and 4x squared, how many terms are in the divisor? There's 2 terms in the divisor, so I'm going to put my first answer 2 terms over over the dividend. So my 4x is going right here. Another way to look at it is that notice 4x landed on top of its like term of 23x. But the easiest thing for me to say is we're dividing by 2 terms, so 1, 2, and we put the 4x up there. Yes?
Why does it matter that it has to be going down?
For organization purposes, could you succeed with this problem with not putting the 4x over someplace else? You could. Okay, I'm not going to say you can't succeed, but organization-wise, it helps me kind of know when I get done. Does that make sense? Okay, so now, once that 4x is on top, what do I do with that 4x? Multiplication? Okay, on the last problem we were doing, we were always taking something times 12. This time we're going to take whatever it is times x plus 5. So I'm going to take this 4x and multiply it by x plus 5. which, if you need the visual, it's like doing a distributive property. We're going to take 4x times x, and we're going to take 4x times 5. So that's your visual there. So 4x times the x in my divisor. What's 4x times x? 4x squared. Goes under the other 4x squared. And then 4x times the next term, 5. 4x times 5 is 20x. That ends up under the 23x. And then we're going to subtract. 4x squared minus 4x squared. 0. If it comes out something other than 0, backtrack. You haven't done something right. You need that first term to be 0. And then 23x minus 20x. 23 minus 20 is 3x. Now what? Bring down the next term. So I'm bringing down the minus 16. Repeat the process. This time I always go back and use this x, and this time I'm trying to figure out x times what gives me 3x. So x times what is 3x? X times 3. I'm going to put that 3 over the minus 16. And then I'm going to take my 3 and I'm going to multiply. I'm going to take this 3 and multiply it by the x plus 5. What is 3 times x? 3x. 3 times 5 plus 15. And I'm going to subtract. Remember, you're subtracting everything in that bottom row. 3x minus 3x. 0, as it should be. Be careful. Negative 16 minus 15. Negative 16 minus 15. Negative 31. You can do, I think, yeah, I have it on the board from last period. Negative 16 minus 15. Keep, change, opposite. That's what I taught in middle school. Okay. What is that negative 31? That's my remainder. What's my quotient? The answer up there. So it asks me for my quotient and my remainder. I've got a quotient of 4x plus 3. I've got a remainder of negative 31. Okay. Got a gist of the long division? You saw it? You absolutely love it, right? Yesterday was worse? Okay.
Yeah, 2 days on yesterday.
I know. Okay. You've seen an idea of long division. As I said, I don't remember seeing anything in homework that said you had to use long division. I think everything in homework can be done with synthetic division. So that's why I want to turn the page and work with some synthetic division. As I said, it's brand new. So you're going to have to follow with me to let me help you figure out the setup and everything. But once you get the hang of it, it's pretty nice. Okay? Synthetic division. The key is we work with just the numbers. We don't work with the variables. And so by eliminating the variables, that kind of makes life a little bit nicer. Okay? So, this problem says use synthetic division to divide this expression by x minus 2. And it asks for the quotient and remainder. So, start by looking. We are dividing by x minus 2, right? So, when we set up synthetic division, we're going to set up a little box here. And in this box is going to be the number that we are using to represent x minus 2. So, if you think of x minus 2 as a factor, what number represents that x minus 2? And in other words, if I set this equal to 0, it would be x equals 2. So I'm going to put a 2 in my box. So assuming they give you x minus 2 or a linear factor, like x plus or minus a number, basically grab the number and use the opposite sign. Now, next to this 2 in my partial box, we're going to do a row of numbers. The row of numbers are the numbers that represent each term, so the coefficients. Now, always make sure all place values are represented. So we start with our highest power is x cubed. What's the coefficient or the number in front of x cubed? 1. So I'm going to have a 1. What is my number in front of my x squared term? Negative 14. What's in front of my x term? 51, and what's my constant? Negative 54. Do beware, if there's a missing place value, we'll have to put a 0 as a placeholder. So just beware when we get to the next problem. Okay, leave room for a row of numbers, and then I draw a line. Okay, step 1 is always to drop this first number. So I'm going to drop this first number, which in this case is a 1. And that's where my answer is going to be. My answer is going to be related to these numbers we get down here. So we drop the 1. And then we're going to repeat the steps, multiply, add, until we get done. Your multiply always goes back and uses the 2. So I'm going to take the 2 that's in the box. I'm going to multiply it by my number on bottom. 2 times 1 is 2. And I'm going to bounce that up above and put it underneath my next number. So it goes underneath the negative 14. You can't zone out for a moment. You'll be lost. Don't zone out, okay? So, I dropped my 1. I did 2 times 1 and got 2. Yes? Then I'm going to add. So we're going to add our column. So I'm adding negative 14 plus 2, which is negative 12. Now we're ready to go into a repeat process. We're going to multiply. We go back and always use the number in the box and your most recent number on the bottom. So 2 times negative 12. 2 times negative 12 is negative 24. That's going to bounce back and go under the 51. So that was the 2 times negative 12 under the 51. 51 plus negative 24. Because I am adding. What is 51 plus negative 24? 27. After we add, we go back and multiply. Always using my box number, so 2 times 27. What's 2 times 27? 54. Bounce it back up above the bar. And then we're going to add. Negative 54 plus 54. 0. If you had to guess, what would you guess that 0 represents? The remainder. Okay? This last place value right here is always your remainder. In this particular problem, my remainder happens to be 0. I'm not saying my remainder is always 0, but my remainder happens to be 0 in this case. Your answer comes from the numbers 1, negative 12, and 27. And this is where we have to put variables back in for our final answer. Okay, so we dropped off the variables, and now we're putting them back in. Now, think, my original problem was x to the third, but we divided by an x, which is going to take and drop away 1 power and make it x to the second. So this 1 right here represents 1x to the second. It will always be 1 power lower. The minus 12 is going to be minus 12x, and the 27 is just plus 27. And you have done synthetic division. It's new, there's a lot going on, but I promise if we practice a couple more times, I think you'll find it easy. Okay? Well, and honestly, that's the only time you're going to see me putting all those arrows in today, because, I don't know, someone last period asked me to write out the steps, and I tried to write out, like, what I was multiplying and adding each time, and they said that helped them. So I could try that on the next one if you want. But it's just a matter of figuring it out. Now, before I move on real quick, the question was, what is the quotient and remainder? So, what is my quotient? X squared minus 12x plus 27. And what's my remainder? Remainder of 0. Could you have done that exact same problem using long division? Yes, you can. Okay. Yes. Yeah, it's going to, the number that goes in the box is going to come from this factor you're dividing by. X minus, so it's always going to be opposite the given sign. Okay, so stay with me on the setup of this next problem, please, to make sure we don't overlook an important detail. But again, it's asking me for synthetic division, right? We're dividing x cubed minus 57x plus 56 by x minus 7. Okay, first of all, number in the box. If we're dividing by x minus 7, you're going to put 7 in the box. And keep in mind, this synthetic division only works when you're dividing by x to the first, plus or minus a number. It doesn't work with higher powers. Now, what's my highest power here? X cubed. What's the number in front of x cubed? 1. What comes next? After x cubed, what should come next? Officially, there should be an x squared there. Is there an x squared term in this problem? No, so you have to put a placeholder 0 in. So there's 1x cubed, 0x squared, because there's no x squared term. I really should zoom that in. I'm really zoomed out. Sorry, guys. And then what's on the x term? Negative 57. And then the constant term is 56. Okay. Are you ready? And I can try and write the steps out. It's just me writing the numbers out of what I did. It's hard for me to put the steps in words, but first thing we're going to do is what? We're going to drop the 1. So if you want a step, it's drop the first number there. So we drop the 1. Then I'm going to multiply, add, multiply, add, multiply, add. What do I start off multiplying? The 7 in the box times my 1 on the bottom. 7 times 1 is 7. Then I'm going to add 0 plus 7, 7. Repeat the process. Now again, we're going to multiply. What am I multiplying? 7 in the box times my last number on the bottom here. So 7 times 7 is 49. And that 49 goes up above the bar, below negative 57. Now I'm going to add negative 57 plus 49, negative 8. And again, I'm going to multiply 7 in the box times the negative 8 here. 7 times negative 8, negative 56. And we're going to add 56 plus negative 56, 0. What does that 0 represent? That is my remainder. What is my solution?
Take the whole thing together. X squared plus 7x minus 8.
I like it. Because my original problem was x cubed. This one represents x squared. And then go down from there. So 1x squared plus 7x minus 8. Is that a little better? Again, as I said, the more you practice, I think the easier it gets. I really do. It seems confusing, but learn the process, it's easy. Okay, moving on to example 3 if you're ready. Example 3 says again to use synthetic division. Now, notice if you started ahead of me, back up and make sure I had a typo. There's a sign change here, if anyone started ahead. So we're going to use synthetic division to divide these. Notice we're dividing by x plus 5. There's a typo in the notes. Notice the final directions. Write the polynomial completely factored. We'll have most of the work done. Our synthetic division will help us factor. And in fact, that's what my pre-cal kids have been using synthetic division for lately, is factoring. So, okay, are you ready? What goes in the box? Because I changed that and made it x plus 5, in the box is negative 5. Okay, what goes next to the negative 5? It's 1x cubed. What about x squared? 7, the x term, negative 38, and the constant term, negative 240. Leave room for a row of numbers. Draw your bar. First step is to drop the 1. And those will always be 1s, but they are for right now. Then what do I do? Negative 5 times 1 is negative 5. Then I'm going to add 7 plus negative 5, 2. Where'd all my help go? Then I'm going to multiply. Negative 5 times 2 is negative 10. Then we're going to add. Negative 38 plus negative 10 is negative 48. Then I'm going to multiply. Negative 5 times negative 48 plus 240. And then I'm going to add negative 240 plus 240, 0. Again, what is that 0? Remainder. Okay, now, if they want me to write this in factored form, the remainder better be 0, or I can't factor. Okay? Because if the remainder is 0, that's what tells me something is a factor. What does the 1, 2, negative 48 represent? Since this was originally x cubed, 1 power less is x squared. So this is x squared plus 2x minus 48. We also divided by a factor. What does this negative 5 represent that we divided by? Negative 5 represented what? X plus 5. So the whole idea here is we've been asked to factor this. What we did by using synthetic division is we took the factor x plus 5 and we divided it. Divided this and we got x squared plus 2x minus 48 as our other factor. Now, is this completely factored? And here's the deal. Can x squared plus 2x minus 48 factor? Yes, you should know that. So x plus 5 is going to stay x plus 5. X squared plus 2x minus 48 should factor into 2 parentheses. X squared is x and x. I need 2 numbers that multiply to be negative 48 and add to be 2. Negative 6 and 8. And now, is this completely factored? And now it's factored. I don't think we have that in today's homework. I mean, you could find zeros if you had to, right? That would be easy to finish off. But I think they just are having you factor. I think. Okay. Example 2, I just want to look at the first one here. The idea of the remainder theorem. Okay. If you get a remainder of 0, what that tells you is that, yes, this is a factor. If you get a remainder other than 0, it doesn't factor. Now, in my brain, the easiest way to find a remainder is to, what have we just been doing? Synthetic division. I think that's a pretty easy way to find a remainder. And that is one good option. The other good option, and I think, Matt, if you go into question help, I think Math Excel would give you this option. But it says if you divide a polynomial p of x by x minus a, then the remainder is P of A. And let me explain what that means using our first example right here. Given this function, dividing by x minus 3. Now, think with me. X minus 3, if we go put that in the box, what number is going to go in the box? 3, right? And so that is what you would plug into the equation that would also help you find the remainder. So I'm going to show you two different ways to find the remainder. You know, the password that never works when you need it to. So when we set up synthetic division, it's x minus 3, so in the box is going to be 3. You have to have a grasp on synthetic division. What they're saying when they talk about P of A here, that is if you're trying to find the remainder, you can take that 3 and just plug it into the equation. You don't have to do synthetic division. You can just plug it into the equation and that would find your remainder as well. Some of you will like that as opposed to synthetic division. Some of you will like synthetic division. But they both work when you have to find a remainder. So when I say find P of 3, what's my P equation right here? That means I'm going to take 3 and every place I see an X, I'm going to plug it in. So 3 to the 5th minus 2 times 3 to the 3rd minus 3 to the 2nd plus 2. And with a little bit of math, you could do that, right? Or some of you are going to say with a little bit of calculator, you could do that, right? And so I will tell you, I'm not going to take the time to do the math right now, but that works out to be 182. That 182 is your remainder. What's the other option here? Synthetic division. And I want to go through the synthetic division with you. Check your setup. First coefficient is 1x to the 5th. What needs to come next? An x to the 4th, and there isn't one, so we're going to say 0. X to the 3rd has negative 2. X to the 2nd has negative 1. What else is missing? Just a regular x term, so we're going to have a 0 and then a 2. I guess here's my thought. I tend to not use a calculator in things unless I have to. And that other one, to do it without a calculator, would be a little bit harder for me. Okay? This one I can do real easily without a calculator. And I think some of it just depends on what else you're doing, you know. So, I'm going to go through this kind of quickly. Maybe while Stacy's announcing. Drop the 1. Multiply.
Sorry to interrupt you. Can I have your attention for a few end of the day announcements? Students in groups 9
Multiply.
through 12 wanting to make a schedule change for second semester need to stop in the high school guidance office no later than tomorrow. There'll be no schedules adjusted after this date for second semester.
Multiply.
Tomorrow will be DJ Day for middle school and
Multiply.
high schoolers, sponsored by Middle School Student Council.
Add.
You can donate a canned food item, bring a toy, or donate $1. Don't forget your COVID procedures. Outside of tonight, we have wrestling at Clinton Central, and we have girls basketball at home against Frankfurt. We'd like to welcome both teams. Tickets for the Frankfurt game tonight at home will be sold only online, so if you need a ticket, get on the athletic website and buy a ticket. Thank you. Have a great evening.
Okay. Give me another minute of your time. I have something else to write down here. Okay. I finished the synthetic division while Stacy was announcing. Okay. 182 is my remainder. If you do the math here, 182 is your remainder. When they ask you to do a remainder, I don't care. Do whichever way you want. They're both good. Now, here's what I want to talk about real quick. If you're asked, is x minus 3 a factor of that? When is something a factor? When the remainder is 0. So would this be a factor of the original one? No. And you will be asked that in homework. Okay? So I'm just going to comment here that this is not a factor. And it's not a factor because the remainder does not equal 0. Okay, so I wanted to talk about that real quick because you will be asked that in homework.
How many questions are there?
I want to say homework is 10 questions maybe. And I think most of it you can do synthetic division for, if not all of it. Okay?